Today in our exegesis, we shall be delving into the applications of optical instruments, and today our focus will be on the simple and compound microscope. Now, simple microscope and compound microscope are both instruments used to magnify objects, but they differ in their design. Number 1, magnification power. Number 2, and application. Number 3. This gives us the triune similarities between the simple and the compound microscope. The simple microscope or magnifying glass is a converging lens used to produce a magnified and virtual image of small objects. The object is placed between the principal focus and the optical center of the lens. The lens is brought very close to the object and a magnified, virtual and erected image is produced. The image being displayed on your screen is the diagram of a simple microscope, which is magnifying glass. Its major component is the medium, which is the lens used, and the lens used here is a concave lens, which is converging lens. From the diagram, our triune components of a simple microscope include the medium, the lens, which is seen in between the center of curvature C. Then we have our object AB, and then our image A prime, B prime. You can see the object as a flame of fire. The object is placed between the principal focus and the optical center of the lens. The lens is brought very close to the object, and then the image has a triune component, which include magnified image, virtual image, and erect image is produced with that converging lens. The observer is in between X and Y, and you can see that he is able to see a magnified image of the object AB very clearly. What are the triune components of simple microscope? Number 1, the medium, which is the converging lens, which is the concave lens. Number 2, the image itself. The nature of image formed include magnified, they are virtual, and they are erected. Number 3, the object. The object to be viewed by the observer is part of this. Now, what are the functions, the uses, and the applications of the simple microscope? Number 1, they are used for reading small prints. Number 2, they are used for studying biological specimens. This uses a single convex lens to magnify objects. Its magnification power is typically limited to 100 times zoom ability. They are less expensive and easier to use. They are ideal for observing large specimens like insects or coins. Now, what is compound microscope? The compound microscope, on the other hand, consists of a combination of two converging lenses. One of the lenses is called the objective lens, which is the object, and the other is called the eyepiece. The objective lens is nearer to the object, and through the eyepiece, the final image is seen. The two lenses are of short focal length, but the eyepiece has a comparatively larger focal length. The diagram as seen on the screen illustrates a compound microscope. We have the object labeled as A and B. A real and magnified image I1 is formed in front of the eyepiece at the point labeled B. Now, A prime and B prime. That's the first image. Then the eyepiece is adjusted until the position of the first image is nearer to it than its principal focus. The eye, which is the eyepiece, function as a magnifying glass and is magnified, but virtual image I2, which is the final image, is formed A prime prime, B prime prime. We have the principal focus of the objective lens as FO and the principal focus of the eyepiece as N. What are the triune components of a compound microscope? Number 1, the objective lens, which has short focal length. We have the eyepiece, the imagery. It has a larger focal length, and then the observer himself that would observe the image of the object in the end. Now, the objective lens and the eyepiece, The objective located closest to the object relays a real image of the object to the eyepiece. This part of the microscope is needed to produce the base magnification. The eyepiece located closest to the eye or sensor projects and magnifies this real image and yields a virtual image of the object. What are the uses and application of the compound microscope? They are used for studying tiny objects. One advantage of the compound microscope is that it produces a higher magnification than that obtained from a simple microscope. But there is a disadvantage. This denotes that the final image, even though it is magnified, is inverted. This is, however, not a problem in studying tiny objects, since the observer can adjust the eyepiece for the image to be at his near point of vision. Uses and application. Another aspect, they use multiple lenses, and this achieves higher magnification. Magnification power can range from 40 times to 1000 times or more. They are more complex and more expensive. They are ideal for observing small specimens like cells or bacteria. A simple microscope uses a single magnifying lens to produce an enlarged image. In contrast, a compound microscope employs multiple lenses. In summary, a simple microscope is a good choice for basic observation, while a compound microscope is necessary for studying finer details.
Connect to our social media handles at Physics Bible, the Triune Physics, for latest update. Thanks for joining us. Stay equipped, stay liquid.